So this week I've been told that you guys started simple linear regression as well as like left join, like you're still tidying data, right? But so the interesting thing is that there is a connection, although it's not always obvious, right? Because left join is something you tend to do when you want to merge your data sets together, but sometimes the type of merge you actually do depends on what you want to do with your data, right? So in the context of like simple linear regression, if you have missing observations, you may think carefully about which particular function you use to join your data. Yeah, so we'll kind of discuss both those things like simple linear regression, because that's what you're doing right now, where you just have one covariate you think predicts Y, and then we'll do a lot of tidyverse stuff, like tidying up your data sets. Okay, so this is I don't know if any of you heard of Tidy Tuesday, but it's a really neat worldwide thing where you get a data set on Tuesday, and it's kind of a bit of a competition in some sense, although there's no prize, as to who can make the best graphical display or make sense of the data you're actually given, right? So you're given really messy data that isn't necessarily always nice, and the thing is you want to find patterns or trends for data visualization that you kind of share on Twitter or on your GitHub or whatever. So this is one data set, right, from Tidy Tuesday. It's on mobile use across the globe, right? So you have to ask yourself, like, did they partition the mobile use across different continents? And they did, right? So if we have a look at this, so readr is what you use as a function. You know, I'm kind of using a function you haven't seen before, but readr is what you use when you want to extract. So I'm using the tidyverse read underscore CSV, but I'm pulling from an online CSV file, basically. So I'm using readr because I'm pulling from an online CSV file, right? And I wanted to kind of recognize where the delimiters are itself without me having to download the CSV file and upload it on my own. And this is actually kind of good for reproducibility, right? So if you want to reproduce, you know, the work, so tidyr is, I think it's, sorry, readr is its own package, I think. But anyways, the thing is, if you want to produce reproducible kind of codes and stuff, it's good to kind of use, you know, readr or whatnot, where you can kind of install it, or you can kind of download external CSV files without using it locally. So one issue we have in statistics, we always use local files, or we kind of save into our own server, but that doesn't help us reproducibility, because when you want to post your code online, people don't have access to your local files, basically, right? So the one thing that's kind of important for us to do is kind of learn to use functions when we want to share our code that allows us to use, you know, external databases without having to, you know, read it locally, basically. So this is what I did here with the readr. I'm reading the database but not locally, right? So I'm doing it so that people can kind of, when you guys look at the code yourself, you can run it as well, because obviously I put this thing here. So you can also run it as long as you have this readr package installed. Okay, so this is what we get. We get this this database, and you can see that it has different codes, right? So you can see that you get Afghanistan, you get Albania, etc. So you get different countries, and then you get different continents. You get the continent with the countries in, right? This is kind of an important thing, right? Because we're going to talk about linear regression, and now you have to ask yourself. I'm gonna show you a funny plot. And you guys are gonna tell me what happened, basically. So you get, not only you get the country itself, you get the continent it came from, right? So Afghanistan's in like Asia, whereas Algeria is in Northern Africa, right? So you also get the total population within each country, and you get the year, right? So you see Afghanistan's changing across each year, basically, right? And then you get mobile subs, basically, like, you know, how many people are using mobiles within each year, right? So you can see that it's probably going to grow exponentially in each country, right? Maybe it will grow exponentially in the countries that are most developed, but that growth rate is going to be related to population size as well, right? So countries with bigger populations will obviously have, you know, larger mobile subs. And so this means that when you want to build an LM model, you may want to account for the population size before you talk about, like, you know, like mobile use and its change per year, right? So if you're looking at mobile use per year, you have to also adjust for population, because that's going to influence, right, the mobile use in that sense. Okay, so let's look a little bit further. I kind of showed you what the data looks like. So we have filtering and tidyverse first. It occurred to me, right? I was looking at this data set before class, and I didn't realize at the time that you not only got the content, you got the country as well. Because what I did was something funny, right? I first said, okay, let's look at the population change within each year, right? So if I want to know, how does population change over across the globe? And that means I don't even look at the countries, I'm just looking at the population growth in general. So the select function, again, remember, allows you to go across the column space. So you can see that in the original mobile data set, I have 7 variables, but maybe I don't want all of them. Maybe I only want a small amount of them. So when I run population, I'm only going to select 3 of them. So this is working across the column space, which means the number of observations should still be the same across both databases, but the number of variables you have is going to be smaller, right? So keep in mind that when you think about what you want to do with your data set, make sure you're making sense of things, right? So it's not that the number of population, it's not that the actual observations should go down, it's the actual number of variables you have that goes down, right? So the select function, I'm gathering year, content, and total population. So what do I get? I got this data set, right? So if I look at you see that it has the same number of observations. So we had initially we had in the mobile data set, we had, let me go back up here. Oops. If I go to dimension of mobile, right? So dimension of mobile, you can see that initially we had, 62, 177, which is the same number of observations we have, but now we have, instead of having 7 variables, we have 3. So we could view population, obviously, out of curiosity, just to confirm that's what we have, and you see we get this. So where I messed up here was I realized that I should have actually included, and now I'm realizing as I'm teaching it, I should have included the actual entity itself, which is the countries, because look what happened when I actually ran it. So I was like, okay, let's look at the years, and then look at the population growth per year, and somehow it's going to show me something linear, basically, or at least it's going to show me an exponential growth. But I got this thing here, which looks crazy, right? So I got this really ridiculous graph, and now it's occurring to me, right? And it's funny because when I kind of continue to subset, I still didn't get it, right? So I was thinking to myself, okay, this is, it's clear here that something is going on, that you get different population growth each year, right? And so this could be a function. I thought it could be a function of the continent, right? Because you notice that initially, while I pulled continent, I didn't actually ask for it in the actual ggplots. I was just looking at years versus population. And so I thought to myself, maybe I need a subset based on, right, continent. So it's not enough to just look at year versus population growth, because you can see that each particular graph may have linear growth in some sense, but it's happening in different parts of the graph. So we have to do something more. Okay, so I kind of said, this is kind of a disaster, right? You can see that, oh, this is spelled incorrectly. This is a disaster. We have different continents may have their own population growth, but that's still not quite right, right? So what I did here is, like I said, maybe I just look at one continent. I just look at Africa, for instance, because the population growth we know in Europe and North America is kind of slow. So we would expect to see probably, if you look at this graph here, probably North America and Europe is somewhere down here, basically, in the very low population growth. So that's not a very steep curve. It doesn't really make linear regression that interesting. So I was like, let's look at a country that is very big population, right? Which naturally is Asia or Africa. They have bigger populations, so we could look there. And then I got this, right? And so it still kind of looks completely choppy, right? So if I compare this to this, I still haven't figured out what was wrong. And now I just realized what the issue is here. I need to consider the fact that within Africa, the Horn of Africa is different from, like, Northern Africa, which is different from Sub-Saharan Africa. They all have different population growth. So I need to actually, consider the countries themselves, which is so funny, right? So if we go back and we actually select, so you can see what I did here is I filtered. I took the population data set that I made, and I asked just, so this is going across the row space now, right? So filter goes across the row space. So I said, let's look at the content of Africa. And then I said, okay, now if within Africa, let's look at the relationship between year and population growth. And I still got the same issue, right? So the issue is that, to address the question, it appears that we have, different population growths within each country. So we can't, we need to further subset our data. There's actually something you could do here. There's something called a random effects model. And I guess in theory, you could, if you want to look at the population growth and the content of Africa in general, you could introduce a random slope effect and even a random intercept where you take the countries to have their own, you take the countries to have their own starting point. So they have their own slope and they have their own rate of change in terms of the population growth. But it's probably easier to just subset the data. So I realize I messed up here. We should have probably selected entity as well, which is the country. Right, so let's go back and do that. So I'm going to select from the original mobile data. So this is the, the original mobile data set is up here, but I'm going to actually select. Oh, I want to select. I'm going to add something. So you can see that initially I didn't have the entity, but now I'm going to include it basically. So now let's go here and let's call it population 2. So I think it's called entity maybe. Let me just check the original. Mobile. So this is, yeah, entity. It's called entity. So let's add that in. I want to call it population 2, actually, not 1. Okay, so now let's see dimension of population 2. I just want to see if it worked. Yeah. So now you can see that this is what the new data frame looks like. And so the reason why I'm doing this is because I need to, instead of looking at the continent, which doesn't really make any sense, I need to be a bit smarter here. Right? Probably I need to look at the actual countries, right? So for instance, if I want to look at, if I want to look at Afghanistan, right? I could do something like, maybe actually lowercase, so I can, I'll kind of just shorten it so I don't have to write it all out. So if I do something like, population 2, then I do something like, filter. Now because you can see that, now why I'm going to use filter here, if you look at, population 2, you're going to see that across the row space, if I want to just select Afghanistan, I selected across the column space initially to get this variable here. But now if I want to filter across particular countries within a continent, I have to actually filter according to row space, basically, right? So let's do that. So I need to do this, and this is actually a mistake here. Okay, so filter is going to be, entity equals Afghan. Right. Okay, so you get this, you get 28 observations. There are actually 28 observations from Afghanistan. You can see that this is the population growth across from 1990 to 2017. So you actually you have missing information, by the way. Here, you don't really have information past 2013, but anyways, now that you subset it according to country, I don't believe that we'll have the issue where we have a bunch of lines, because when you have a bunch of lines, because you have different countries with their own population growth. So now let's see what happens if we look at Afghanistan, right? And we just look at, X equals year, Y equals total pop. And let's see if it works. Yeah, so this is the coordinate system, right, for the total population in Afghanistan per year. And then if I add geom point, I don't think I should get, unless there's per city kind of population growth, but they don't give us that kind of, we don't get any more, I don't get a finer partition than this. So the finest partition we get is according to country. Unless they give us city, I shouldn't see multiple lines, because this is the finest partition I can get from my data. Yeah, you can see you get one line, because there's nothing, I cannot go finer than country, right? They don't give me city. So this is the finest I can get in terms of population growth. And you can see that it looks linear. It looks like it's increasing. Now I could do linear regression on this, ironically, right? So now that I've filtered as much as possible. So this is when you have really messy data, in the sense you get multiple partitions based on country and city. And this is when you start making use of the filter function. So to reiterate, you can see initially I had a big issue because I had all these lines that were corresponding to different countries within each continent, right? So even when I actually partitioned based on just the content alone. So you can say, I said, let's look at Africa. I still didn't get what I wanted because there's too many countries within Africa. And that's the issue. So now here's me saying, let's look at Asia and let's look at just Afghanistan. If you look at Afghanistan alone, you get a linear population growth for just that one country, right? So now I could obviously, if I wanted to, look at things like, geom smooth and add a linear regression, because that's what you're doing in this, right? So you're doing linear regression this week in your assignments, although only simple. And if I don't put, so if I put, let's put standard error equals false, just so we can see what, if I put false, I won't get the confidence bars. But let's see what we got. So you get this. That's actually pretty linear, ironically, right? This is actually freakishly linear because I haven't even transformed this in log scale. Well, look at how well the line tracks, the points actually track the line, right? So this is a really strong linear relationship and it's positive, right? So I've never really seen anything like that, because usually you either see exponential growth or something funny, like, but this is kind of interesting. But anyways, we could actually look at the model. So we can look at model, let's call it A for Afghanistan. And then this is, he introduced guys to the LM model because you're doing linear regression, a simple case. So now we know that Y is going to be equal to, in this instance, total population, right? And it's a function. So this, when you put squiggly line, it's like a function of year. So make sure you have in your mind, right, what it is that you think is X and Y. Because if you do it the other way around, you're then saying that you think the year is a function of total population, which doesn't make any sense, right? So then Afghanistan, you can put data equals Afghanistan because it won't run otherwise. And let's see what we got. Okay, so we get this, the model runs. Now let's look at our summary. So when you put summary of model, that's when you get like, that's when you get the output, right? So here's what we got. What do you guys notice? So this is the coefficient is really strongly positive. Does anyone see what you notice? So how do you know if this is if there's a significant relationship between the year and population growth? So the question is like, is it true that the year is strongly related to population growth? Is it true that, for instance, it's going to, within each year, you have a certain proportion of population growth and it's consistent basically? Because to have a linear rate of change means that, so to have a linear slope means your rate of change is like constant, right? Every year you add a constant amount of people to your population, right? If you take the derivative of that slope, you get a constant rate of change. So you're consistently adding a certain proportion of the population each year. So what is this? So how do you interpret these coefficients here? This is a kind of funny thing to interpret because you don't really interpret year, but still. Would you guys say this relationship is significant? Like that year is probably a predictive indicator of like your population growth each year? Thoughts? And how do you know? How do you know, like from the output, whether or not your trend is significant? So you have to look at the coefficient. So actually, let me confirm that he actually did he guys show you this output just so I'm not going ahead of the material. Did you guys actually see this output here? I'm not sure if like you guys were, because like he did say in the email that you guys are learning simple linear regression, but I don't know if you guys saw this. Did you guys see this output before in the slides? Yes, no? Okay, cool. So you can see that, so I just want to point out a couple of things. First, the p-value is important to determine. You have to, you have to look at the p-value. That's one thing, right? And I don't think you're going to look at too much. You're not going to look at the other stuff too much. So don't worry about the standard errors just yet, but I would focus on the t-value and the p-value. There's two ways to interpret this. Your p-value is so small because your t-value is so big, right? So if you can imagine what you're actually looking at, you can imagine that you're looking at a test statistic where, it's almost like this, right? So you have a t-distribution that has a long, heavy tails or whatever. Or maybe this is your null distribution basically, right? So this is a null distribution. And your t statistic is so far out, it's like somewhere here, like 49 or something. It's like really in the extreme. So you can see the probability associated with that extreme p-value is very, very low, right? Saying that it's the probability of seeing an observation that extreme, right? If year was not significant, is unlikely, right? So we shouldn't, if there's no relation between year and interest and population growth, you wouldn't see a t-statistic that far in the tails, basically. That's why your p-value is really small, right? So because the bigger your p-value is, the closer it is to the center here, right? So if the closer it is to the center here, so you're gonna have a less significant effect, right? The closer it is to the center, the less significant your actual relationship is. And then if you have that kind of relationship that's where you think is close to the center, of course you're not gonna reject null hypothesis, right? So rejection happens because you're out here, but if you're somewhere like, let's say, over here, like really close to the center, you probably won't feel, compelled to, if you're like somewhere here or something, you probably won't feel compelled to reject the null hypothesis. You just don't have enough evidence. You're too close to the center, right? So this is so you'll always find a very large t-value, be it largely negative in this situation here, or largely positive, so that they're in either end of the tail, right? So a largely negative would be somewhere back here. So we're really looking at the absolute value of t, basically, right? Being largely positive, right? So being, let's say, that much bigger than 0, right? So that's going to be associated with a very small p-value, right? So this is why it's significant. So that's what you're looking in your assignment. You're going to be looking for the p-value, and when you look at the p-value, if it's significant, you'll see a very, very large test statistic. But if it's not significant, if your p-value is like, let's say, if your p-value is bigger than 0.05, you'll notice your test statistic is kind of close to 0. It's going to be small, basically, right? So that's something to look for in your assignment. And you can play around with this, by the way. You could take any country you want and look at the line. Not all of them will have the same effect, because you can see that what we saw with Afghanistan is pretty strong, right? But how do we know that we'll see that with like other countries? You could look at, like, let's say Algeria and Africa and see something totally different, right? So if you run this is pretty strongly linear, but we have no reason to believe that it's going to look like this for all the countries, because some countries may have very slow population growth. In particular, if you go to like Norway or like Spain, where it's a very old population, let's say in Italy or Spain, you may see a slower population growth, right? So I encourage you guys to play. It's kind of cool. Anyways, we could also look at the pivot longer and wider functions, right? So pivot wider, you might want to, if you're interested in, for instance, looking at like certain trends within each year, you may want to pivot wider, right? So in this data frame here, you can see that it's kind of in long format. So if I go back to view of mobile, it's really in long format, right? So notice that the year is going like this. This is actually long format. I may actually want to look at it in terms of wide format. In what sense? Well, maybe I want to look at particular years. Maybe I don't want to look at the entire set of years. Maybe I just want to look at like 1991, for instance, right? So in this way, you may want to pivot wider, but maintain. So you might want to maintain your variables within each year, basically, right? So I'm going to pivot wider from values from year. So I'm going to pivot, when I say names from year, I'm pivoting wider according to year, right? So I want to, in some sense, I want to look at the actual mobile subs, like who are using mobiles within each year, basically. And so the values are coming from mobile subs. So let's look at mobile. I called it mobile 1, not very creative, but So you get this basically, right? So notice that you're going to get for each country something. So in Afghanistan, for instance, you're going to get in Afghanistan for each year, you get the mobile use, basically, right? So this is what it's doing. It's literally translating it, and then you're going to get the content it's coming from. It's going to tell you Afghanistan's in Asia, and from 1990 to 2017, here's the actual mobile use. So you're going to get it across each particular country, and then you're going to know the content is coming from, basically, right? So for instance, Andorra is in Europe, and here's this mobile sub use. Now, some countries don't have any information. You may want to filter those countries out when you want to do data analysis, because it doesn't really give you any information, basically. So this is why you might want to look at wide format. You may also want to look at wide format as well, because it kind of tells you, in some sense, where you're missing information, right? So you can see that, for instance, in Antigua and Barbados, right? You really don't have much information past 1990, right? And then Gula, you don't have any information at all. Basically, you can probably look across the data frame and you can see that there are multiple countries where you have no information, right? So here you can see in Bonaire, there's actually no information at all, right? So you got nothing across each of the years, so you cannot use that, obviously. Whereas the British Virgin Islands may have some information in some years, but not all. But you can see that there's multiple ways to play with this data set by using these codes, right? So, and if you're really interested in the cool thing about this, that if you're interested in looking at just, for instance, again, particular countries, so let's go back for a second. If you're interested in, for instance, looking at, you just want to look at, for instance, Afghanistan across the years, you can just pull the whole thing, obviously, and then you have a wide format. You can translate it back to long format if you want to, right? So it gives you a way to scan your data properly and pull out the things you want. So if you just want the first couple of countries or something, you can just, you know, filter across the rows and then pivot longer to put it back in long format. So you get a lot of cool features when you use the pivot functions, right? So obviously, when you have too much missing data, you may want to remove it. If you think that you get nothing, if you get absolutely no information, you may think to remove that data, in which case you may use like the filter function to get rid of the things where you have missing values, basically. Okay, I just put a note here that select works across the column space and filter works across the row space, because these are the things that when I was first doing the material, it kind of confused me, right? So I would always say, why can't I use select or select across the rows? But then I realized that you only really use it to select variables themselves. So both are pretty useful functions, but they're doing different things, right? So make sure if you want to select observations, you use filter. If you want to select variables, you use select, right? So I'll put a note here, i.e., so in a nutshell, if you want to select variables, you use select. But if you want to select observations, you use filter, right? So these are different things, basically, and intuitively. There's one other thing I wanted to point out. I wanted to point out that sometimes you have to be a bit careful because you cannot use a select function on numerical things. That's why I kind of use a silly example, because this is something that will frustrate people eventually when they come up with the assignments and they realize that some of the header names. So if you look at the mobile one we were looking at, it had, so let me see if I can find it here. You can see from mobile one, the column names look numerical, basically. Right, so if you make a mistake of putting in select and you put 1991 as a numerical thing, it won't actually run an error, basically. That's why I wanted to point it out, because you may eventually, be it in your final projects or in an assignment coming up, who knows, run into a situation where you're getting confused. And you don't know why you can't just put 1991 without the quotations or whatever data frame you're working with. You just want to put in numbers, and you might want to know why the heck, like for instance, this isn't working, right? Why can't you do this? It's because you cannot put in a numerical thing into the select function. It doesn't like it. You have to put a string, basically, right? So I'm just going to pretend I want to pull the continent of Asia, right? So this is mobile one, filter. So this is me filtering the continent of Asia. And then within Asia, I want to select 1991, basically. So now if you look at this, it's a variable. It's a data frame with only 1 year, basically, right, of mobile use. Just be mindful, like I said. You cannot put in 1991 without the quotations. It doesn't make any sense, right? So we can actually run it and see that it will say, there's an issue. What happened here, right? It doesn't like it. So you see that doesn't say, it literally says 1991 does not exist, right? So you have to, go back and use, pretend 1991 is a string, basically, and then it will run, right? So it's a string basically across the variables, the variable space. It's not actually numerical value. Just kind of a thing to keep in mind, or it will drive you crazy when you go and look at your own filtering and you wonder why you can't get it to run, basically. But yet you're convinced that the column name is 1991 or something. Okay, so now let's go to merging in tidy. So in your assignment, I think that you have something where you have to use left join. So Ken said he wanted me to go over it, right? So if you have any questions about it, you should ask, right? Because I think it comes up on your assignment this week. In fact, in particular, there's a difference between left join and inner join. They're doing similar things, but not quite, right? So you don't embellish on your code if you don't have to, because you may end up embellishing in a way that's not quite right, right? Because if, for instance, you ask you to use left join and you use inner join, you're not doing the same thing and you may get different results and then it's not right, right? So don't embellish if you don't ask it for you. If you're asked to use left join, use left join. Why is that? Because tidyverse has multiple functions. So they seem to be doing similar things, but they're not quite. They're doing slightly different things and we need to recognize this, right? So in particular, there's two functions that look really similar to each other, but they're not, right? So we have something like inner join that returns also, if you're looking at inner join, and we're going to do an example, it returns like all the rows where X, all the rows from X where there is a match with Y. So if you're looking at the rows in X, you want to know, you know, where on, like you want to, in some sense, sync with a Y from a different data frame, basically, right? So you want to match basically between X and Y, right? Now, if there are multiple matches, it does a one-to-many match, basically, right? So if you have a variable X, if you have a row from variable X, and you want to match it to, for instance, a variable Y. And by the way, this matching tends to happen with a common key. Right, so if you want to match X and Y, there needs to be a common key to merge those two things together, right? So usually there's a key that's an ID, maybe you usually use ID or something as a common key, and then you merge X and Y based on the common key. But for instance, if you have inner join does the following: if there are multiple matches between X and Y, it will do a one-to-many mapping, right? So it will do like something like this. So given pretend you have a common key, which is ID. So you have data frame 1, D1, and D2, data frame 2, right? Then they both have common IDs, right? And then you have like X, the variable X here, and you maybe have the variable Y here, right? So now you want to match X and Y based on this common ID, right? And so what will happen is that like if X, you know, let's suppose X is like, I don't know, you know, what's a one-to-many mapping? I can think of the back of my mind. Let's suppose you have something like this. I don't know. 2 goes to, you know, so 2 and 4 go together or something. I don't know, like this. And then there's got to be some one-to-many map I can think of. Oh, let's see the following. I have this as well. I have something like, let's go the other way around. Let's have something like this. I have 4, right? And then here I have something like Y is like -2 and 2. And the mapping is something like, you know, you want to map like X squared or Y squared equals X. This in mathematics, let's say we're looking at this, but you can think of this like in variables as well, right? So I'm going to do something like this. Obviously, there's a in some sense a many to one mapping basically, right? So it will do something like this basically. Recognize that like this is the case with these two match here basically, right? So this is what inner join does, and in fact, not only does inner join do it, left join does it too. It also matches, right? If there are multiple matches between X and Y, all the combinations are returned. We'll literally look at all the combinations between X and Y and map them together, right? So anytime you have multiple matches, it will map them all together. But the difference between the two things is that with inner join, if there is no mapping, so for instance, if a column of, if you're looking at an observation of X, for instance, and it doesn't have a match basically, right? So let's suppose it's something like this. Right, so you have X, you have -2, you have 4 and -2, 4 and 2, but then you have something like the following. You have like you know, an observation down here. So let me erase this. So you have 4 and -2, 4 and -2. So it's saying that it's the same. These are the mappings, and then you have something like this. It's something like, I don't know, 16, and then you have a missing observation here. It's missing, and then you have like, let's say 25. And like 5. So you can see that this is missing basically in your data set. So you have this missing observation here. Inner join will delete it basically. So this is the thing to keep in mind. If you don't want to delete your observation, if you don't want your observation to be deleted, you cannot use inner join. So it seems like they're doing the same thing, but they're not. So when you have missing observations, so if your Y column is missing, we'll seriously delete that observation. We'll say, okay, well, there's no match. Let's get rid of the entire row. So it will delete the entire thing here. And you're just left with the other 3 matches basically, which is problematic, right? So when you're merging, you'll just see the following thing. You'll see like ID, and then you'll see like X and Y basically, and it'll show something, it'll show for, it'll show, oops, that's not right. Whatever the ID happens to be, I haven't specified, whatever the ID happens to be that you merged across, it will show something like for, -2, 2, then it will show, 25, 5, but it will cut out the 16 because it doesn't have a match basically. Right, so that's not what you want a lot of the times, because sometimes when you want to do data manipulation, you actually want to treat your NAs as missing observations. You may want to actually impute or you want to do some implementation to take care of the missing observations. So you don't want to delete it because it may be informative in some sense. So you need to be a bit careful here. Basically, instead you may want to use left join, because left join will do the following. Instead of deleting out the observation, we will put NA. So you'll see you'll have another column here. So we'll just put NA basically, right? So if I go back to my example and I kind of erase a bit, it will do something like, 16 NA, and then it'll put the last observation of 25, 5 basically, right? So it doesn't delete the observation, it says it's NA, and then you would use your comment and say, hey, maybe that's actually supposed to be 4. So you would fill it in yourself basically. Right, so you don't always want to remove observations, because if you know how you can impute it, or you can fill in the missing observations, like in this case here, you would put 4 basically. You wouldn't want to delete that observation, right? So you have to be careful. They're not the same thing, and if you feel like the NA may be informative, you may not want to delete it. So this is probably why he told you to use left join, right, in the assignment, and not inner join, because there can be some issues logistically when you remove observations, right, that you're not supposed to. So keep this in mind. So if you look at your code and stuff, it's okay to use other functions that he doesn't tell you to use, but make sure you know what you're doing with the functions, right? Don't embellish too much in a way that you get something that's kind of off the scope or not making sense with what you want to actually show in your data. This is actually especially important in linear regression, right? Because a lot of times, if you take too many observations out, it does have implications in your regression model. Okay, so let's see how, and I'm going to show you guys the difference between those two things. It's kind of cool. So band members is a thing in Tidyverse. So Tidyverse has a lot of built-in data sets, which I think is kind of cool, right? In particular, it has band members from the 80s, I think, and maybe even the 70s and 60s. I think they're, even in the 60s, from before any of us were born. So you can see that it contains the artist and their band. So for instance, Mick Jagger was a part of Stones, and you have John Lennon and the Beatles, Paul McCartney and the Beatles, etc. So what am I going to do here? But each of these members in these different bands play their own instruments, right? So that's kind of the cool thing, right? So each of them play their own instruments. So we can obviously match not only the name of the person to their band, but to the instrument they play too, right? So this is band members in Tidyverse. We also have something called instrument, so band instruments, right? So again, we have the band members and the instrument they play. So for instance, again, John Lennon played the guitar, Paul McCartney played bass, and then Keith, I don't know what his last name is. He played guitar, etc. And I wonder if I could see what the dimensions of the band members are. I'm curious how big this data set is. Oh, there's only 3. So that's kind of funny. It's a very small data set, actually. Notice that this is the entire set. So you can see here that there's not complete overlap, right? So if you look at these data sets, this person has Mick Jagger. This data set has Mick Jagger and Stones. But this one has Keith and guitar. So there's one frame where there's no overlap, basically, right? So now, what happens if I use inner join versus left join, right? So if I use inner join to join the band instruments, the band members, what happens? So we said that inner join kind of is, the situation where you remove observations that don't have a match, basically. So you can see that there's a match across 2 of the variables. So if you're matching based on name, because that's a common link. So again, the common link between those 2 things is name. So I may match based on name, right? And so when I do it, I get, I get a 2, I should really say 2 by 3 tibble. I only got 2 observations because it says it recognized that Mick Jagger and Keith are not really, they don't really link. So what it does is just deletes, it doesn't find a match there, so it will delete things basically, right? There's no match. So when you go back to, you know, Mick, when you go back to, when you go to band members, which is here, it will say that, well, you know, Mick Jagger doesn't have a match in band instruments, so I'm going to delete his observation basically. And that's okay in this context, I guess, because it's a silly data set, but you can imagine in a situation where you actually want to see your missing values, it may not be great, right? So in contrast, if you look at left join, it will give you it should give you a 2x3 table. And I really should say it. I should really say 3x3, right? Because I forgot the name also counts as part of the observations. So it's 3x3. Anyways, this is the same command, except I put left join instead of inner join. And I got this 3x3 table basically. But you see that I put NA here because it recognized that Mick Jagger doesn't have a place. But you could look it up yourself. So the reason why you wouldn't want to delete is because you could look it up yourself and you can see that Mick Jagger plays probably something, right? I don't really know because I think he's before my time, but he plays some instrument. Maybe some of you know. And I'm curious. I want to look it up. So let's see. He looks like he was a lead singer. I don't even think he played instruments. Oh, he played the guitar. There you go. He played the guitar. So we could look it up on these in Wikipedia. We could probably put guitar basically. So we could fill it in ourselves, which means it doesn't make sense to delete his observations. This is why you may want to use left join. Now I want to point something out. If you change the order of the join basis, so if you change the order so that like you're inner joining band members to instruments. So if you were going to do the following, you know, band members, band instruments, and you do something, you know, inner join band members, you're going to get something the opposite. Now your X becomes Y and your Y becomes X. So what you achieve is the following. Right, you get you still get the same. I just want to see if it's the same. Let me see. You still get the same, I think, here, but where you get something different is when you change. Where you get something different is in the next one, because now let's see what happens when we use left join. It will do something funny. So you have to. That also reminds you to be careful about the order of your actual join, basically. All right. So if I do the following here, notice that this one was like, you know, oops. This one was like Mick Jagger, Johnny, Paul, but I think it should say Keith, if I'm not mistaken. Let me see. Yeah, you see, it will say Keith now, right? Because it will say Keith because your X became Y and your Y became X. So be careful, basically. You have to know what you want to actually show in your data. So this is another lesson here, basically, right? So, you know, this will change, you know, this changes Y to X and X to Y. So be a bit careful, basically. So whenever he asks you on your assignment, right, I'm gonna do the same thing here. If on an assignment you're doing LM model or something and you're asked to do inner join, you're asked to do an inner join or something, or you're asked in general just to do inner join or a left join, which I think you're asked to do. And make sure you know the order in which you're doing the join, because it will actually mess up your data frame and then you may get an answer different from his own, not because you didn't know how to run the code, but because you ran it in the wrong order, basically. So this is a kind of check and make sure that your order of operations makes sense, or you may end up with a data set that you were not supposed to get, and then your output's not going to look like Ken's, right? So be mindful of this. Make sure you know what X and Y happens to be when you're joining your data sets together, right? Okay. So why do we get the 3x3 table here? It's because obviously we add an extra row of NAs because left join does allow you to do a mapping from any missing observation to NA, basically. Okay, so now let's go back to our trusted data set and look at simple linear regression once more. Although ironically, I realized that I did it up here, right? So I realized I also did simple linear regression here. But anyways, let's look at this again, right? So this is the MT cars data set. I want to look at, so last week I said that I was surprised, but then I thought about it and I said, not really, when the miles per gallon was actually going down as a function of like how the more you weigh. Like you actually drove, you know, your car was slower when it was heavier. And then I was surprised and I realized actually that makes sense. You move slower when you're heavier, you move faster when you're lighter, basically, right? This is even true for runners, right? They always say that you shouldn't run competitively if you're above a certain BMI because it could be bad for your joints, right? Because you're not supposed to run too fast when you weigh past a certain BMI. And that's actually even true for cars, basically. Certain cars can only go so fast. All right, so I'm going to add a GM smooth, which is LM. And then I'm going to actually show the model again, right, in the summary statistics. So have a look and see that we have this decreasing trend, which is kind of interesting, but I kind of, again, it's expected if you think about the fact that lighter things move faster. And then we can look and see if our model is significant in some sense, right? So if you have a look and see, we get this. Does anyone see if anyone know if our model is significant or not? Is it significant? So this is actually a significant effect because you can see that, well, the weight is negative. So in the other example, it was a positive significant effect. Here it's a negative significant effect because you can see the T statistic is largely negative, right? So the T statistic is largely negative and the p-value is small. So this is, again, check the absolute value of T. The absolute value of T is almost 10, which is large, right? With the small p-value. You can also look at this in R. Basically, if you want to make a comparison to a T statistic in R, you can see that you actually have a T on 30 degrees of freedom because it's n minus 1. No, it's actually n minus 2 in this instance here because you lose 2 degrees of freedom to estimate the intercept and the slope. So your T statistic is like QT. This is the function in R. 975 because it's a two-sided test. And then 30. So you're comparing your T statistic of 9.59 to 2.20. So if you look at the table, you're doing something like this. You're looking at like your test statistic, your critical value is here at 2.04, let's say. And then your T statistic is like 9.5 out here. So obviously you're in the extreme region, so it's going to lead to a rejection of the null hypothesis, right? So the critical region's out here, but yours is really far to the right, right? Because the absolute value of T is obviously like bigger than 9.5. So you're gonna reject the null hypothesis and conclude that there appears to be a significant effect between car weight and miles per gallon, right? Any questions about this? So this is actually the basis of your assignment. Be careful when you're manipulating your data frames, right? Don't manipulate in a way that gives you the wrong data set. So carefully read the question before you actually, especially with the left join and inner join, because if you change the order of the database construction, you get a different database, your output will look different too, basically. So be careful about that. Otherwise, I guess that's it for today. And good luck with your assignments for the week. Yeah, p-value less than 0.05. Yeah. All right. Have a great one, guys.